Welcome back. In this segment we talk about variables in C, the data types of variables, and we'll look at doing arithmetic in the C language. First, let's have a look at variables and their data types. Variables are locations where data can be stored, and the programmers will give them an appropriate name and an appropriate data type. Each variable holds only one piece of data at a time. So you can think of this as a little box. You can put a value in there, some kind of a number, and only one value can be in that variable, that little box, at one time. Each variable has a name and a data type. And we'll look at only two data types to start with, and then in the next segment we'll look at the remaining data types that are used in the C language. So here are some examples of declarations of variables in C. It starts with the data type, so we have double. That's the data type for the variable named tax rate. And we have int total, int count, and then two declared on one line, price and grand total. So we have two data types here, int and double. The int data type is for declaring variables that have integer values only. That means whole numbers, no decimal points. And the double data type is for variables that need to have a decimal point and some degree of accuracy after. The equal sign in these declarations is to initialize the variable to a specific value. So in the line int count equals 0, we're going to pronounce the equal sign there as gets. This is an assignment operator, gets, G-E-T-S. So count gets 0. It puts the initial value of 0 into that variable. If we don't initialize the variable, there is junk in that variable, whatever was left over when that piece of memory was used before. Okay, when you're naming your variables, there are two things to think about. One is the rules that you have to follow, the syntax rules for choosing names or identifier names. And the other one is the convention. The conventions for choosing names don't mean that the program won't compile. It means that people will be able to read your code if you follow the conventions. First of all, let's look at the syntax rules. You can't use a space in a variable name. You may not start a variable name with a digit. It confuses the compiler. And the standard is no more than 31 characters in each name. I don't suspect that we'll need more than 31 characters in a variable name. You can't use reserved words in the language, and you may or may not know what the reserved words in the C language are, but things like if and do and while, you'll get to know what the reserved words are in the language, and you'll just kind of know you wouldn't declare a variable with that same name. So you can use characters, lowercase and uppercase letters, and you can use digits, and you can use the underscore character. Those are syntactically correct. So the convention in C is that you start your variables with a lowercase letter, and you use mixed case for readability, and name the variables appropriately for what they're being used for. Correctly spelling English words as your variable names is kind of important, and there's my famous example now of a variable name that you probably wouldn't want to encounter, WS0321. What would that be used for if it were a variable in a program? And can't you tell it's the water supply in Orlando on March 21st? Well, of course you can't. So we want to write programs that other people can read and understand what the data means, what the computing with the data, and we'll use correctly spelled English words for the variable names as the first way of making the programs more readable. Okay, in this slide, assignment and arithmetic. So we have a place to store values. Now let's start moving values around and computing with the values. So in this example, we have some variables declared: tax rate, total, and count samples. And then there's an example of an assignment statement. An assignment statement, count samples gets 23. And we're going to pronounce the assignment operator gets. And now let's look at some arithmetic that we could do with variables. The arithmetic operators in C are add, subtract, multiply, divide, and modulus. The first four will be very familiar to you, and the modulus operator we'll discuss on its own. So here's an example where we declare a variable A and put 10, and B and put 6 in that one, and another variable result. So here's your first arithmetic statement in C. Result gets A plus B. So the variable result now has the value 16. The assignment operator is not an equality relationship. That's why we don't say result equals A plus B. It's a verb. It's something that happens. So we're going to add A plus B, and then we're going to assign the resultant value into the variable result. The rules for precedence in C are the same as they are in algebra, so add and subtract have lower precedence than the multiplicative operators. If you see them all appearing in one statement, then you have to know that the multiplicative operators will happen first, and you can change the order of operation using parentheses in C the same way as you can do it in algebra. So there at the bottom of this slide we have an expression where the addition happens first, and then the result of A plus B is multiplied by 3, and then the result of all of that is assigned to the variable called result. Now let's have a look at the modulus operator. It's the only one that you probably aren't familiar with just from high school arithmetic. Modulus is sometimes called modulo or just plain mod, and it's also called the remainder operator. So it's a multiplicative operator. It has the same precedence as multiply and divide. And if we write 10 mod 3, what we really want that to evaluate to is how many are left over after we take out as many 3's as we can. So we can get 3 3's out of 10 with 1 left over. So 10 mod 3 evaluates to 1. Let's do some more. 11 modulus 4. How many 4's can you get out of 11? Well, you can get 2 out, that's 8, with 3 left over. You can think of this as 11 divided by 4 has a leftover or a remainder of 3. So that's why they call it the remainder operator. 10 or 1,000 modulus 10 is 0. And there are two special cases that might trip you up. So let's look at both of them with the modulus operator. 6 modulus 9. You can't take any 9's out of 6, so the result is 6. When the operand on the left of the operator is smaller than the operand on the right, then you have what you started with, which is the operand on the left. The second special case is when you have a modulus 0. How many zeros can you take out of 15? I guess the answer is infinity, but if you try to execute that in a C program, it won't execute. So this is called a runtime error. It's different from a syntax error because this happens when the program is running. We try to do a divide by 0 or a modulus 0, then the program will stop at that line with a runtime error. That's something you don't want to have happen. Now let's look at some more arithmetic expressions written in the C language. We have, for purpose of demonstration, declared some variables A, B, C, and result. Probably not good names for variables. They don't follow the convention of using English words. But they do provide us with a way of looking at arithmetic expressions. So look at this one. Result gets a plus 3 times c modulus 2. What happens first? It works the same as in algebra. 3 times c happens first. What's in c? 5. So 3 times c is 15. Then what happens next? Well, the modulus operator is multiplicative, so it's going to happen before the addition. We've got 15 modulus 2. That evaluates to 1 left over. And then we're going to add that to a, which has 10. So a plus 1 has 11. And then finally, the value 11 is assigned to the variable result. When you're looking at arithmetic statements in C, or you're creating arithmetic statements in C, it's imperative that you know the order of the operation. You'll get a completely different result if you're doing the additions before the modulus operator and so on. Okay, we've introduced 2 data types, one integer and one floating point. So we have data types int and double. And when you do arithmetic with different data types, they behave differently. Integer division is the first unusual thing that's happening with simple numbers that you might not expect. So let's look at this example where we declare 3 integers for demonstration, and a has 10 and b has 4. What's 10 divided by 4? Well, you want the answer to be 2.5 because you're used to working in continuous mathematics instead of discrete mathematics. But in this case, when we're using integer variables, 10 divided by 4 is 2. There can't be a decimal point in the answer. So let's think about this for a second. The divide operator, when it has an integer variable on the left and the right, then we have an integer division. The integer divide operator is different from the floating point divide operator. The result of an integer division is an integer. It can't have a decimal point in it. So there's the other example at the bottom of this slide where we declare similar variables, except we use the data type double, and a divided by b this time is 2.5. And we have a different operator. Even though it's the same symbol, it's the / operator, these are different operators, the integer divide and the floating point divide. And which that / symbol is determined by the data type of the operands. So we're doing an integer division in the first one and a double division or a floating point division in the second one. Now I want us to go into the development environment and just play with these, to declare some variables, do some arithmetic, and see how the operators are working. Here we are in the development environment, and we're going to create a new project from scratch. I won't do this every time, just until we get used to it. So File, New, Project. It's a Win32 console application. I'm going to save it in the same folder I've been using for my programs. And let's call this project segment 2. And there is only one more thing. Under Application Settings, we're going to set this as an empty project. So we have in the Solution Explorer these 3 folders. We're only going to use one of them, the Source Files folder. And into that we'll add a new item. And we're going to click on a CPP file, but we're going to instead name our file something.c. So I'll pick variables.c since that's what we're going to play with. And the usual suspects, I'm not even sure we're going to need standard io.h this time, but it doesn't hurt to put these in here. So the main function, an open brace and a close brace, and a system pause just so that we can see what happens, so the window doesn't disappear when we're executing. So there's our starting point again for experimenting with the concepts that were introduced in this segment. So I'm compiling that just to make sure that I didn't do anything wrong with my braces or anything like that. And once it gets to the linking stage, you can tell that it's compiled correctly. And now we're going to declare some variables as we did in the PowerPoint slides. So here's the declaration of a double variable. And a double variable is a variable that can have a decimal point in the value. So tax rate is a variable that is of data type double, and this is an initializer. We're going to read this as gets, G-E-T-S, gets 0.07, so that's apparently a tax rate. And here's some more variables, A and B, not good names. We should use correctly spelled names, and you can initialize those. So an int variable is one that has no decimal point in the number, so it can be positive or negative or 0, but it can't have a decimal point. So you can initialize these if you want to in the declaration, and you can declare more than one on one line. You need to declare all of the variables first before you execute any other statements. So you can get some fairly mysterious compiler errors if you decide to declare some variables after you have written some executable statements. So here are some invalid variable names, 7c, and let's see what the compile error would be if we try to start a variable name with a number, with a digit. And it's not all that helpful, but here are the errors. And if you double click on the first error, it will point at the line that it thinks has got something wrong, and it says bad suffix on number. So that's not exactly what we did wrong, but it should be a clue to what we did wrong. So let's start playing with the arithmetic operators a little bit. There are 5 arithmetic operators: add, subtract, multiply, divide, and modulus. So let's do some very simple assignments first. If we write A gets 10, there's an executable statement. It has to end with a semicolon. And if we write B gets 4, and now we could write C gets A divided by B. So when this line of code executes, we would be saying take the value in the variable A and divide it by the value in the variable B and assign the result to C. So we would have, in this case, 10 divided by 4, and you know that the answer must be an integer because these are all ints, including the operator is an int division, and the answer will be 2 that will go into the variable C. So if C now has the value 2, what happened to the value 12 that we put in there originally? Each variable can hold one value at a time, so the value 12 is gone, overwritten by the value assigned on this line, which was the value 2. Okay, so just looking at this code, how can you be sure that the value in the variable C is 2 when the code executes? Well, we could print it out, but I want to try to encourage you right from very early in the course that you should be looking at the code, the execution of the code in the debugger. So a lot of times students, beginning students in programming, will run the program and it won't do what they expect it to do. And there's a whole lot of lines of code that where something has gone wrong and it's not obvious where the problem is. So if we click out here in the margin, we'll get a red dot. That's called a breakpoint. So instead of executing this whole program, we're going to execute the program up to this point. So if we use the right arrow, the right green arrow, it says Start Debugging, and we're going to start executing the program, and we will stop on the breakpoint. So the yellow arrow is pointing at the line of code that has not yet executed. And down here in the lower left, we have a window that shows us the value of the variables, and you can look at them in different ways. My favorite way is to click on the Locals tab, and now we can look at what is the value in the local variables. So the variable C currently has the value 12, which was assigned here. That gives us the indicator that this statement has not yet executed, because we're going to assign C a new value. So far we know how to set a breakpoint, we know how to run to the breakpoint, and the next thing we need to know how to do is to execute one line of code. So we have these new buttons up here. One says Step Over, and that means execute this one line of code. So we executed this line of code. The yellow arrow now points at the next statement to be executed, and the value in the variable C has changed to 2. So your C programs cannot hide anything from you. You can look at every line of code as it executes and know exactly what it's doing. So as you're getting familiar with the operators and the functioning of the control structures and so on that we'll go over in the next segments, you can watch the code execute and make sure that it's doing what you expect or what you hope when you wrote that line of code. Okay, when you're done debugging, I don't need to look at this anymore. You can click on the yellow, that's not yellow, the green arrow again, and it will just simply finish or continue executing. So this program didn't do very much except pause at the end of execution. Okay, let's change this a little bit just to demonstrate a couple more things. Now we have another arithmetic statement here, 7 plus a divided by b. So when you write a number in an expression like this is called a numeric literal. So the literal 7 has the data type int, and we have 7 plus whatever value is in a divided by whatever value is in b. And the execution of this is done in the order of precedence for the operators. So in this case, we would do the a divided by b first. We would get 2, and then add the result to 7, giving 9, and the value in the variable c would then be 9. And as we pointed out before, you can change the order of operation using parentheses. So now we would have 7 plus a, which has 10 in it, so that would be 17 divided by b. 17 divided by b by 4 is 4 in integer division. So let's look at the modulus operator for just a minute. If we write the expression c gets a modulus 3, so we can mix literals and variables in the expressions, we would have, and we'll set a breakpoint there to see what's going to happen. It will ask us if we want to rebuild because we've changed the code, so you have to recompile every time you change it. And we will stop at this breakpoint to see what's going on with a modulus 3. So the variable a still has 10 in it. In this statement, the only variable that changed was the one on the left, C. So A has 10 in it, and if we say 10 modulus 3, we should have 1. So 3 3s are 9 with 1 left over, and if we execute that one statement, the variable C does indeed have the value 1 in it. Okay, let's continue there. And now we will experiment with a runtime error. So if you have a variable that at runtime has a 0 in it on the right hand of the modulus operator, or in this case we just forced it by putting a literal 0 as the right hand operator, this will cause a runtime error, which is not a compile error, so it's syntactically correct, but it's going to stop at runtime when it tries to execute that statement and concludes that it cannot do this division by 0. So I haven't yet executed it. I'm going to try to execute that one line of code, and the error message is an integer division by 0. So we have now a runtime error, and these are not recoverable. When your program executes a runtime error, it's going to stop and it's not going to start again. So we can try breaking there, and a good way of getting out of this is when you hit a runtime error is to look for this square that says stop debugging, and that will get you back into edit mode where you can fix the mistakes. So dividing by 0 in integer, or doing a modulus by 0, is going to be a runtime error, and you really just have to go back and look at what caused the program to do that and fix it. It's not something that you want ever to happen in the code that you produce. Let's play just a little bit more with some other kinds of operators. If I have a double variable called result, and down here let's put the expression result gets A divided by B. So we're going to address this in another segment later on, but let's look at what would happen if we have A divided by B in integer division and then assign the result of that division to a double variable. So 10 divided by 4 in integer division is 2. And now we're going to assign 2 to a double variable, not 2.5. So this is kind of a tricky part. The data type of the operator is decided by the data type of the operands. So A and B are both int. That means this is an int division, and the result is 2 and not 2.5. So 10 divided by 4 is very different from 10.0, which is a double literal, divided by 4.0. And I could have double variables with those values in it, of course. But just to demonstrate that we get a different value in there, using a double division, we'll run that and watch what happens. Watch what value goes into the result variable. And I forgot to take out the runtime error. So there's a good demonstration of the fact that we cannot get to any lines of code that happen after a runtime error. And I'm not going to edit this out, even though it was my mistake. I'm just going to comment that out and kind of use it as a learning exercise that runtime errors are not something you can recover from, and programmers are not perfect no matter how many years they've been doing. Okay, so now we have a double division and we want to assign something to that variable. It's interesting to note the value in the result variable before it's assigned anything is this great huge negative number, which is quite meaningless. So an uninitialized variable has junk in it. You have to be careful not to use that value in any computation. So 10 divided by 4, 10.0 divided by 4.0, and the result is 2.5. So your program cannot hide anything from you, and you should be using the debugger to make sure that you understand what happens at each line of code. This is one of the big advantages that we have with using the Microsoft Visual Studio. It provides perhaps the best debugging environment that's in existence, and they just have many years of experience with creating tools that help the programmers be more efficient in writing their code and understanding what their code does. In this segment, we've looked at the declaration of variables and the data types that were introduced. So far, only two, the int and the double data type that's used to declare variables. And we looked at the variable naming requirements, the syntax rules for naming variables, and also the conventions that you're expected to use in declaring of variables. And then we started looking at the operators. We saw the assignment operator, which looks like an equal sign, but we're going to pronounce it as gets. A gets B. And the arithmetic operators. There are 5 of them, including the modulus operator, which we looked at in some detail because it's not the same as in algebra. Arithmetic expressions and the order of operation. It's important to know which operations are happening when, and it's also important to know what is the data type of the operator. So an integer division, for example, is not the same as a double division, and if you aren't recognizing the difference between an integer and a double division, then you won't be able to interpret what the expression is actually doing. I know this is kind of boring stuff. We haven't gotten to the interesting things yet. These are fundamentals. We're going to do a couple more segments of fundamentals, and then we're going to start solving problems with the tools that we've used. I'll see you in the next segment.